do you know how to open a Jupyter notebook? In short, can you tell me how do you open a Jupyter notebook? I mean, using Anaconda Navigator. So you open the Anaconda Navigator first, and then you launch Jupyter Notebook. No, 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 don't do that. Don't do that. It will take you years to start Jupyter Notebook. We can't afford to waste an year. Starting Anaconda Navigator takes itself almost around 15-20 seconds. Then after you launch the Jupyter Notebook, and that also will not be launched in the folder of your choice. What I mean by that is, let's say today we are starting with our very first session, and the session is Numpy and Scipy. So what I have done is, as you can see, right now I am in my E drive, ebooks, data science, Python, Eduonix, AIML. I'm in this folder. And if I want to launch my Jupyter notebook from here, okay, you're using PyCharm as well. Okay, but I'm not going to use PyCharm. We are only going to use Jupyter notebook, and that is going to be more than sufficient as well. Okay, so Mohammad Reza Khiabani. What should I call you? What is your first name? Starting with M or starting with K? Khiabani is the surname, or Mohammad Reza is the surname? What is your first name? First name? I guess it's Mohammad. Mohammad Reza itself is the first name. Okay, cool. So, how are you going to launch your Jupyter notebook? Well, let's say if I want to launch the Jupyter notebook in this particular folder, copy this link, right click, copy. Then you are going to, I'll close this because I'm showing you the explanation, right? Close, close, close. Okay. I told you, you go over here. First and foremost thing that you do is right click, copy, then open the Anaconda prompt, as you can see over here. Where am I? You can see right now I am in C drive users English, but I don't want to launch a Jupyter notebook from here. I want to launch it from this address, which I have copied. So I want to change my directory from C drive to E drive right up to AIML. So I typed CD. CD stands for change directory, and I paste it by pressing Ctrl V. Enter. First time it never happens. Just press E colon because we want to enter the E drive, and now the entire path will come. Now when I type over here Jupyter notebook and I press enter, friends, I can launch Jupyter notebook in the folder of my choice. You want to confirm? Please confirm. What things you have over here? SciPy, file name, SciPy Jupyter notebook. You see the same thing? SciPy, SciName, and Jupyter notebook. These things will not be shown in the Jupyter notebook. That's fine. Anyways, they are irrelevant. They are related to some software which I will talk of after some time. So that's how you are going to open. And now, as usual, we create a new Jupyter notebook, and let me give it a name. So I say February 27, Numpy and SciPy. Now, one more thing I want to tell you guys is today's session, though it is related to Numpy and SciPy, please consider it from my experience that among these two modules, both of them are very important. But to be very honest, our main focus for today is going to be mostly, our main focus is going to be Numpy. Okay, just a second. This pen is not working. What is wrong? What is wrong? Just a second. Right. Exit. And once again, I'll launch. get it. Now, I was saying that the agenda for today revolves around Numpy and SciPy. To be very honest, SciPy is standing for Scientific Python. I will talk of it when I come. But if you ask me how the session is going to be broken down, as far as machine learning is concerned, SciPy is something which you can't start off so early because it has good machine learning functions, but all of those can be done alone by NumPy and Pandas as well as sklearn. You may not be aware of these all libraries, but not a reason to worry. Okay, so I would say that our session is going to be somewhat broken like this: 70% of NumPy and 30% of SciPy. And if you ask me why, well, trust me, friends, this is more important as compared to SciPy at this time instant. If I compromise on this, then you are going to have it in machine learning. Okay, you're going to have it very badly. Compromising on this is still okay because this is something which we are anyways going to study gradually down the line in the program. Okay, the same goes with scikit-learn as well. So let us get started with NumPy. So starting with the very first one, NumPy. So friends, the very first one, what is exactly NumPy? Well, NumPy is the considered as the backbone of machine learning in Python. Yes, it is that much important. Will prove you why. Okay, that also I will prove you why. One more important point which I want to talk of related to NumPy is that NumPy is what? NumPy basically stands for, num stands for numerical, I stands for Python. So NumPy stands for numerical computations. Third important cheese which I want to tell you over here is, where do we actually use NumPy? Well, NumPy, what is NumPy? Well, NumPy, it consists broadly of two things. The first thing over here is ND arrays or ND array, and the second is, now you may feel that, sir, why are you writing this? Well, each and every line which I write over here is going to be very important. Okay, I'm not going to write an essay over here, but these points essentially make NumPy. They are very important. Okay, next which I want to talk of over here is NumPy is the backbone of machine learning, and NumPy is super fast because it has vectorized functions. That's it. I'm done with typing. So let's try to understand how all have I written over here. First and foremost thing, I'm going to take your machine learning, and if you want to start your journey in machine learning, this is the very first module that we see, which is NumPy, which stands for numerical Python. So if you know this, then you can go ahead. Then NumPy is used for numerical Python. See, when I say numerical, please understand that NumPy is broadly used to deal with numbers. It is used to deal with numbers. And I'm going to ask you this thing. NumPy consists broadly of two things. One is ND array, one is U functions. So this thing is going to take at least 1 hour for me to explain. So once I complete with this, I will ask you, hey, what is the thing that we have to start now related to NumPy? So I expect a reply from you at that time. U functions. Don't forget this name, U functions. So this is one thing. So what is ND array? Well, ND array is nothing but n-dimensional array. And what is U function? U function are universal functions. Okay. And next thing is NumPy is super fast. Now I would like to comment something about Python. Python, if you ask me, Python is a very slow language. Yes, you may ask me why is Python slow language, slow language? It is so much popular. Well, it is. So it is. There is no other alternative to it. Python is a slow language. So why is Python so popular nowadays? Well, there was no reason for Python to get that popular. The only reason this gained popularity because Google started endorsing Python. Okay, that is the only reason that today everyone is behind Python because everyone is behind Google. So I don't say it's a bad language, but programmatically it is a slow language, useless. And for doing machine learning stuff, we require something which is called as fast. Hey, so which is a fast language then? That comes as a question for us. Well, the fastest programming language till today happens to be C++. Yes, C++. So are we going to code in C++? The answer to that is yes. But wait a minute. Our focus is on machine learning using Python, right? AIML using Python. So what is this C++? Well, here comes the role of NumPy. Okay. NumPy is super fast because it has vectorized functions. What do you exactly mean by vectorized functions? Well, all the functions of NumPy, all the function bodies, all the function body of the NumPy are written in C++ in the background without even you realizing it. So you are going to code in Python only, but internally these functions are written in C++ language, C and C++, and that is the reason they are super fast. Such a type of programming is called as mixed programming because I'm using Python as well as C++. Now this is only for your understanding. If you ask out in the audience, so many people who are learning machine learning, they don't even know that NumPy supports fast vectorized operations. The back end of NumPy is written in C++. You are lucky to know it. Okay, so NumPy is super fast because it has vectorized functions. Okay, cool. Now, having understood this, now we can start with the very first thing in NumPy. This is done. So I say, let's start with the very first in NumPy, which I told you is my ND array. So now the question is, what is exactly ND array? Well, ND array stands for an n-dimensional array. Friends, NumPy is nothing but used for storing an array. Now you may ask, sir, what is an array? Well, an array is very similar to that of a list, and you know it very well what is a list, right? So an array is very similar to that of a list. So how to create it? First and foremost thing you got to understand is you need to import NumPy. And for importing NumPy, NumPy is a module or a package which has lot of functions. So for importing NumPy, you need to write import NumPy, and that's it. Then if you want to check the version of the NumPy, you can write NumPy dot underscore underscore version underscore underscore. So this is the version of NumPy. Now, depending upon which version of Anaconda you have, this can be up or down. But there is absolutely no reason to worry, not even a single thought about that. Whatever you get, that's fine. That's fine. Okay, now after this, well, we don't write NumPy like this. Usually we prefer to write import NumPy as NP. You know, by NP I'm giving NumPy an alias name, so that now instead of calling numpy.version, I can use the pet name called as NP. So I can say over here, instead of writing print numpy dot this, from now onwards I can give it a name and say numpy dot underscore underscore version underscore underscore, and that gives me the same answer. So I have done that. Now another thing which I want to talk of over here is, why only NP? Can't you give any other name? Well, you can assume it as a de facto standard to label it as NP. You may ask why? Well, if you open any research book, internet blogs, internet articles, YouTube, anywhere you go, everywhere they will refer NumPy as NP. So it's better that you also get into the same habit, because today so many resources are available online, so many resources, and everywhere you will find NP dot. Okay, so it's good to get accustomed to what everyone is using, so that if you are copying the code from the internet, which is usually a very standard practice nowadays followed, which I also support, honestly speaking. So when you copy, you don't have to do a lot of rework in labeling the functions every time. So that's how it is. Now, how to declare a NumPy array? Well, for declaring a NumPy array, the syntax is pretty simple. np.array, it's the function. And this NumPy array function takes as input either a list or a tuple. Okay. So I say, if I just convert it for looking at the syntax, so I say it is going to take as input either a list or a tuple. Usually we prefer to give it as a list only. So if I say I want to store it in ARR, so I say np dot array, and let's say I'm going to give a list over here, maybe 10 comma 20 comma 30 comma 40 comma 50, and when I print ARR, you can see that this is printed. Now how is it stored? I will tell you, but let us check the type of it. So the type of it can be checked as type of ARR, and as I promised you, it's a NumPy array. Okay. Now all the functions of NumPy are accessible using np dot. Okay, there's so many functions of NumPy, so many. I mean, you can see so many functions. It's not practically possible to cover all. So we are going to focus more on the functions which are required for data science. So the very first function which we want is called as ndim. Ndim is going to tell me the dimension. So if I say, hey, what is the dimension of ARR? And when I execute it, it says it's a one-dimensional vector. So let me focus more on this thing sometime. Now, how is it stored? Well, you have a NumPy array 10, 20, 30, 40. Now, you may say that, sir, is it really exactly like list? Well, honestly speaking, yes, it is not different from that. It supports the concept of forward indexing and it supports the concept of backward indexing. So let us try to access that and then I will explain you more about ndim. So I say over here, hey, can you print for me ARR of 0? That is, what am I doing over here? I am asking it to do the indexing operation. What is ARR of 0? It's 10, and that's perfect as well. Similarly, if I say, can you print for me ARR of 3? Obviously, ARR of 3 is 40. What is ARR of 31? Error, index error, because that index doesn't exist. Cool. Then I say, hey, can you tell me what is ARR of -1? ARR of -1 is 40, right? Do you get it? ARR of -1. Okay, we have 50 as well. I didn't store it. I'm sorry. So let's drop it over here. So ARR of -1 is nothing but 40. Now, in the same way, I can also perform slicing operation. Okay. So if I say print ARR for slicing operation, exactly like list. So I will not get into detail. If I say 1:3, okay, 1:3, that is my slice is going to go from index location 1 to index location 3 minus 1. So it is going to pick up the values from index location 1 to index location 3 minus 1. That is everything from here to here. That is exactly 1:3. So 20 and 30 is the expected output of this. And when I try this, yes, I get that only. So such an operation is called as slicing operation. That makes sense. Okay. So at this point, everything is clear. So now I would like to throw light on another data structure with NumPy, which is 2D. As you see over here, what has ndim written me? Ndim has written me 1. That means it's a one-dimensional structure. And looking at the figure also, it's pretty much clear that it's one-dimensional. What is two-dimensional? Two-dimensional structure is a type of structure in which there are rows and columns. over here there is just a single entity which is running from 10, 20, 30, 40. Finish. What is 2D? Well, what if I say that I got to store something like this? Let us say there are 3 rows, 4 columns, and the values are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So how many rows and how many columns are there over here? There are 3 rows and 4 columns. Well, again over here also indexing exists. This is 0, this is 1, this is 2. These are my row numbers. This entire thing is my row 0, this entire thing is row 1 and row 2. Similarly, this is column 0, 1, 2, 3. Column 0, column 1, column 2, column 3. You get it. So if you want to create a structure something like this, how are you going to do? Well, the simplest thing says, NumPy says, I don't understand a structure like this. So what you can do is as a jugaad, okay, just as an alternative method, you can think of right from here to here is 1 row. Yes. Then from here to here is another row. Then from here to here, I have another row. So I have how many rows stacked above each other? 3. And let us put all of this into a single list. So, well, you know what? Internally, actually, I have written for you the code only over here in the diagrammatic form. So if I want to create a 2D structure, something like this, then the simplest hack over here is, again, I'm going to use the same function. So do you mean to say that I'm going to write once again numpy.array? And the answer to that is yes. Then in the entire bigger list, I'm going to store the first one, which is 10, 20, 30, 40. And that you can move down if you want to. Then the next one is going to be what after this? 50, 60, 70, 80. 50, 60, 70, 80, comma. Next after this, that's going to be 90, 100, 110, 120. And now if I say, hey, can you print for me ARR? Well, yes, it exactly prints as I told you. Point number 1. Point number 2 is, now if I say I want to check the type of this ARR, well, you can still see it is a NumPy ND array. That's exactly, we are talking of that, right? Next, after this, I say, let us look at the dimension of it. So I say print dot ndim of ARR. And now you see over here the number has come as 2. And what was the number over here? 1. So now I need to understand one thing from you. Are you clear with the ndim function? Is that thing clear to everyone? Very good. Error is throwing. Oh, you are practicing with me, Pranit? Don't do that, Pranit. You will be down the line lost. If you want to practice with me, I have a solution for you. Hold on, Pranit. Okay. If you want to practice along with me, first of all, I will not give you any additional time for that, but I have a solution for it. Well, how many of you want to practice along with me? How many of you want to practice along with me? You can just reply in the chat here. Okay, Larry replied. I'm doing that. Okay. Okay. So since you're doing it along with me, first of all, it's not advisable. Point number 1, because now since I'm at the very beginning of it, I'm going a bit slow. I may have to increase my pace because a lot of things are coming. Okay. So anyways, I'll be sharing with you the notebook and you can do it. Or if you still want to do it, there's a small hack. I want you to just do a very small thing over here. I just want you all to go over here, go to this website. Please go to this website, and after going to this website, just sign up over here using your Gmail account. That's it. Only do that. Please don't use your office accounts. Sometimes it may give some problems. Use your own account. Please sign up, and just like you have Ingle Darshan, just like I have Ingle Darshan over here, you should be getting your user ID. It's just a matter of 10 seconds. Okay, that's exactly what is required. If you are done with that, immediately reply in the chat section D. D means done. Okay, if you are done, reply in the chat section with a D. Okay, let's wait for a few more people to complete. Just sign up with your Gmail account. You can also use GitHub, but I would prefer Gmail only. Okay, very good. Now, I'm going to share with you this link. You can observe when I open this link by pasting it in my browser, you can see exactly the same notebook with each and everything I have written. The beauty of it. And if you want to execute it along with me, what are you going to do? Listen to this. I'm only going to explain this to you today. Later on, I will never explain this. Okay. So now if you want to execute it along with me, you just need to click over here on this run. And I would advise run on Collab. Okay. You can choose anything, but I would advise run on Google Collab. Google Collab is another version of Jupyter Notebook with the help of which I can run my program in the cloud. That is, I'll be running it on the Google platform. So you can see this tool is very similar to Jupyter Notebook. As you can see, you need not execute this cell. This is what I did. And if you want to execute it, you just need to click on this play button. First, it establishes connection. Therefore, it's taking time. After that, it is way faster than your computer because it uses the Tesla's GPU, which cost today $3,000. $3,000. Okay, it's that fast. The GPU which Google offers free of cost. Okay, and when I execute this, so now you can practice along with me. So now every time I write a few lines of code, I will click on this commit button. Once I click on this commit button, then automatically the code will get changed over here. Okay, change means whatever I have written will come over here, but it will not get reflected automatically. You need to click on this refresh button. And after clicking on refresh button, once again, you need to go over here and run on Collab. Or I think even if you straight away refresh this Collab notebook also, it gets reflected over there. So that's how you do it. So you don't go wrong. At the same time, you get the hands-on. Makes sense, right? That's a good option. Happy? Very nice. Cool. So now, Roy, please change your messaging to everyone so that, if you ask any question and if I answer it, that would be great. So that when you ask a question and if I answer it, everyone would be thinking that to whom is sir asking when no one has asked the question. That's the only reason for that. Perfect. So now, I'm not going to commit every 2 minutes. Maybe in 15 minutes, once I will commit. Perfect. So wherever I think that I'm discussing something at that time, I will click on commit because commit takes around 10 to 15 seconds at worst case. Aquasi. Good to know this trick, but I wanted to watch and listen. Most welcome. No need to execute. I am anyways not in favor of that because listening is going to be better. See, ultimately, I'm going to share with you the notebook, right? So that's not at all going to be a problem. You can execute it any time, any point of time. Not only now, anytime. So invest 100% of your attention in understanding the things. So cool. So now you understand what is ending function. all the NumPy functions are accessed using ndim. You know what? It is saying that, hey, it is having a 2D structure. That's fine. But how many rows and how many columns are there? Vaibhav, hi Vaibhav. Please mute yourself. Thank you. Okay. Again. Akhil, please mute yourself. Yeah. Okay. So I was saying about this particular thing. Where was I? Yes, ndim function is clear. Ndim tells me that yes, this is a 2D structure. So now after that, there is one more thing. And if I say over here, the name of the array is ARR, it's not a NumPy function. It's not a NumPy function. I would say shape is an attribute. What is the difference between function and attributes? See, functions always have this round brackets after this. Do you see round brackets after shape? No, right? It's an attribute. Okay. 90% of the times you will always see functions only. Only few of the attributes are there, and shape is one of it. So I will tell you 2-3 attributes in today's session and almost 50 functions. So you can understand what is the ratio of it. So it says, hey, there are 3 rows and 4 columns. So if the data structure is 2-dimensional in nature, it says there are 3 rows and 4 columns. Okay. In the same way, if I want to apply it over here as well, I can say it ARR.shape, and when I execute it, it says over here, what did I store? 10, 20, 30, 40. So it's a 1D structure. Yes. So what is the output? Does it say that there are 1 row and 4 columns? Friends, I told you, right? I mean, how is this represented? Something like this: 10, 20, 30, 40, 0, 1, 2, 3. This is our ARR in this case, and in this case, this is our ARR. So when I look at the shape, please don't do a blunder by saying that, sir, we also see over here that it has 1 rows and 4 columns. No, 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 no. It is a 1D structure. They have clearly said it is 1-dimensional. When it is 1-dimensional, there is no concept of rows and columns. For 2-dimensional structures, there is concept of rows and columns. So over here, if you look at the shape, what does the shape attribute tells me? Shape attribute simply tells me how many values are there inside this. How many values are there? 1, 2, 3, 4. Therefore, it gives me the answer as 4 comma. Now you may ask, sir, then why is it giving 4 comma? Can't it simply print 4? Why this confusion? Well, to be very honest, it is actually represented in the form of a tuple. So if it is really a tuple, then ideally it should be something like this, right? Why this additional comma? Tuple, single value tuple is represented like this. Well, here's the catch. Single value tuple is not represented like this. In Python, if you want to represent single value tuple, it has to be ended by a comma, else it will never get stored as a tuple. I'll prove it to you. So let us say I add a cell. Let's say I want to assign, let's say, a value 4. So you think it's a tuple because it's a round bracket. So I say, can you print for me the type of t and type of t? That's fine. So we're thinking it's a tuple, right? It's not a tuple. Why? Because Python is smart. In this case, over smart. It is dropping the additional brackets around the number and considering the number as 4. So to make sure that 4 is considered as a tuple, you need to ensure this comma. So single value tuple. This is the way to write a single value tuple. That is the reason you are getting over here 4 comma, because it is telling that the output which I throw is in the form of a tuple, and because it is a 1-dimensional structure, I will only tell you how many values are there over here, and there are 4 values. Therefore, you have 4 comma. As simple as that. Whereas if you look over here, it is a 2D structure. When you ask me what is the shape, I say it has 3 rows and 4 columns. Is the shape attribute clear to all of you? Yes. All clear? Yes, no, no, yes, y, n, y, n. Perfect. Now, next, just like a shape attribute, there is another attribute which is called as d type. I will prefer to write it over here only. So I say print arr dot d type. It's again an attribute. Okay, it's again an attribute. So when I execute it, it will say it is int32. So what does it mean? Well, whatever values we store inside this particular array, what data type it is, it will tell me that. So they mean to say that all the values stored inside this array are integer. Yes, they mean to say that only. So what if I say, or what if I think of having a value like 20.0 over here? So what will it print? In the earlier case, everything was integer, so it was considered as integer. But the moment you convert any of the values to a float, it will convert everything to float, and therefore float 64. So moral of the story is it can consist of only one data type. NumPy arrays are always of a single data type, singular data type. They cannot have a combination of int, float, string, etc. And if you try to do that, it will be converted into a single data type. So this is what we see over here. Similarly, the same thing will happen over here. If you say one of this value is converted as 90 point, entire matrix gets converted to float. Okay, entire matrix gets converted to float. You can look at the d type, it has converted to float. Okay, so that is one thing which I wanted to talk of. And another thing after this is we are talking of this 2D array, right? In this 2D array, let's say if I want to print the entire row 1, when I say entire row 1, it is 50, 60, 70, 80, entire row 1. So how do I print? Well, I say in my ARR, I am interested in printing the entire row 1. That's it. So I get 50, 60, 70, 80. Let us say I want to print the number, let's say 100. Where is 100 located? 100 is on row number 2, column number 1. How to write that? I can say print ARR of 2, 1. That's how you write it. Row number 2, column number 1. And you get 100. There is one more way of writing the same thing. Instead of writing this, you can include a comma over here as well. That also gives us the same answer. But I am accustomed to use this. Okay. Now, I can also say over here, print ARR of square bracket, square bracket. If you execute that, you get an error. But if you put colon over here and colon over here, what does that mean? Well, something very interesting which I will like to talk of over here. Whenever you are doing indexing operation and you use a colon, then that means all. Number 1. And number 2, I will like to talk of over here is whenever you are using indexing operation over here, the first is always for row and the second is always for column. So what I mean to say over here is, hey, go to ARR array and get me all the rows and get me all the columns. Go to ARR and get all the rows and all the columns. So now I get a choice, right? I can say over here, print ARR, get me all the rows, but only of column number 1. So I want all the rows only of column number 1. So only column number 1's rows would be selected. So if I say only column number 1, that means 20, 60, 100 is expected. And would I say column number 1 is all the rows of column number 1. So why am I not getting it? All the rows of column number 1, 50, 60, 70, 80, all the rows of column number 1. Yes, okay, comma was expected over here. All the rows of column number 1. Okay, that's how you do it. Similarly, if I say print for me ARR of, now I need to write over here, I'll replace it by a comma, okay, that will be better for us. So I say over here, I need to give all the rows and all the columns. So I say, hey, I want all the rows of column number 1 up to column number 3. It's also possible. Now this is for all and this is for slicing, because whenever you specify the start and end index, it is slicing. So what I mean over here is I want all the rows of columns 1 to 3 minus 1, right? Because it's always start index to end index minus 1. That is, I want everything of column, I want all the rows of column 1 and column 2. Column 1 and column 2, all the rows, what are they? Column 1 rows are 20, 60, 100 and column 2 rows are 30, 70, 110. And that's exactly what you see. So these are the different ways you can do operations. Now, let's go ahead. Something very important. So we declared NumPy array, right? And we were very happy with it. So I will take one such NumPy array. And now I say, we know that if I do this and if I take the rr.d type, it is going to be integer. I also told you that if I happen to change one of this value to a float, it will convert everything to float. Some students, I mean, almost in every batch, everyone asks me that why is it printed as 10 point, 20 point? Why not 10.0, 20.0? Well, see, that is NumPy's style of printing it. You can't object that. That is how it is. Okay, no debate on that. That's how it is. So that's how it is. Similarly, one more thing. What if I say, can't I store some string inside NumPy? Maybe like my name. So if I say over here, let's say Dr. Darshan English. So that makes sense actually. Why can't I do that? Let me check. And if you do that, as I told you, it will store everything of the same data type. And you see everything is converted to string. And the proof is there are single quotes. And the data type is U17. Well, U17 stands for string. Don't stress too much on this data type. It stands for string. You will not gain anything by peeping into this. So just understand it is standing for Unicode 17. Another way of representing the string things. So now the thing is, can I also have complex numbers, maybe like 5 plus 89j in the NumPy array? The answer to that is yes. And when you have complex number as well over here, you realize over here that still the importance is given to strings. So we understand that string is having the highest precedence. But you know what? I would like to show you something very interesting. Functions of NumPy. Well, NumPy has very interesting functions. I can say np dot sum of ARR. So that's going to tell me the sum of this array. 10 plus 20 plus 30 plus 40. I got the sum. Okay, I can do the sum, same thing over here as well, because it is integer numbers and I get the sum as 100. So you can see the difference, 100, 100.0. That's fine. Now, instead of sum, I can also have min as the function. I get the minimum value. Instead of this, I can also have max as the function. I get the maximum value. Instead of this, I can also use median as the function and I get the median of it. Instead of this, I can also use the min, max, median. Let's say mode will not work over here. Then standard deviation, and I'll get the standard deviation of it. Similarly, instead of this, I can also say, I don't know whether it will work, but sqrt and square root. So every number's square root is given. So what is square root of 10, 20, 30, 40? I get over here. So I see, wow, a variety of functions work over here. And now I copy all of this. And I try to paste it in this array, cell number 39. Here, notice there's one value which is point, but when I do it, I get the same answers. The only thing is the outputs are coming in float for some of the cases, but ultimately we know that for interpretation, they are one and the same. So it hardly matters to us. Okay. Now, the next question which comes to our mind is, what if I copy this and paste it over here? Control enter. And this is the most dangerous case. Why? Because look at the fourth line where I am trying to sum up. So can I sum up these all values? The answer to that is no. Therefore, you get an error. So I'm just going to freeze this to raw NB so that you can execute it whenever you want. Similarly, over here, when I have complex and strings, I convert it again, I get an error. Again, let me convert it to this. So what is the moral of the story? The moral of the story takes you back. As I told you, every line is important. Numpy stands for what? Numerical Python. What is numerical? Numerical, you remember I wrote the numbers. Why numbers? Because NumPy is designed to work with numbers. If you are performing any string calculations over there, then that doesn't make sense. Understand the purpose of designing. If you are going to drive a Ferrari in our Indian terrain conditions, on our Indian road where there are a lot of speed breakers, on every speed breaker, it is going to screech its back, right? The bottom of the car. It's not designed for that. We get it, right? Similarly, if you try to drive a sedan on a hilly terrain, it is going to brush up everywhere or it may get up stuck over there as well. So understand the purpose. NumPy is designed for working with numbers, not with strings. Although it accepts it, that's just being generous about NumPy, but it will not be able to do most of the operations. So that's why I say never use NumPy for all these things. Point number one, clear. Now, next important thing, I have done a commit. Do I need to share the link again? Obviously not. The link will remain the same. The link will remain the same. You just need to refresh over there. Okay. Now that we have understood these all things, let us go to the next functions. The next function over here is called as the zeros functions. So NumPy also has some special functions and one of it is called as zeros function. What is zeros function going to do? Let us look. So if I say np dot zeros, I need to pass over here some dimensions. Let us say 2, 4. That means I am asking him to create a matrix of 2 rows and 4 columns containing all zeros. You see over here, whatever I wish to, I can pass over here 2 rows and 4 columns. I want to change it. Hey, I want 4 rows and let's say 7 columns. You see over here 4 rows and 7 columns. And you know what? I can also say that, have you done that? Wait a minute. Now that you have calculated this, okay, so this is also going to print the same thing. If I execute, immediately I say, hey, I don't want that. I want the shape of that. It tells me it is 4 rows and 7 columns. So it is going to look at the shape of this and it is going to tell me that. I can also use function composition over here. In fact, I will tell you one more thing. I can also say, so you know that what is the output of this? Output of this is a tuple. So when it is a tuple, we also know how is it saved. It is actually being saved over here. 4 is over here, 7 is over here at index location 0 and 1. If I want to access only the 7, can I do that? Yes, certainly you can do that. How to do that? By writing 1 over here. So if I execute that, I get 7. So can I say over here, just to say it on a more sophisticated note, that the number of columns are comma and this. 7. So this makes clear. Larry, I'm coming to that. Hold on. I'm coming to that only. But this is what did strike me. So therefore, I thought of explaining this again. So everything clear with this shape of 1. This one. Which one, Pranit? Pranit, we know the output of this is nothing but exactly right from here to here. It's one and the same. So what is the output of this 4,7? This 4,7 is a tuple, Pranit. So when I say it's a tuple, it is going to be stored something like this. This is 0 and 1, right? So I want to access the number 7 over here. Where is 7 present at index location 1, right? Therefore, I say square bracket 1. Simple, normal tuple indexing. Clear to you, Pranit? Perfect. Now, coming on to the most fundamental question, which only Larry asked. Ideally, I was expecting everyone must have asked. So what is the use of such a stupid function? I mean, why will anyone like to create a matrix of all zeros? Well, I would say that it is used in your machine learning and deep learning, specifically when you deal with images. I'll tell you my real-time experience when I actually started learning machine learning. In fact, almost after 8 months, I realized, oh, this is the place where np.zeros is used. Earlier, I never even bothered to think of why is this zeros function even existing. I said, okay, that's there just for time pass. But every function that we study over here has a significance. So numpy dot zeros is going to create a matrix of all zeros, and it is very popularly used whenever you are dealing with the image processing stuff in your deep learning application specifically. Okay, so at that time, Larry, you will realize the importance of this function. Right now, please just put it into your memory that these functions exist. Okay, similarly, just like zeros, Larry, you also have, you can also give, first of all, it can be in the form of tuple also, but I will not prefer giving it. Similarly, I can also have ones. That's also allowed as well. Cool. Similarly, I can also have twos, threes, fours, fives, six. I'm just kidding. You don't have it. You only have zeros and ones. Other than that, nothing exists. Okay, zeros and ones, because they are very popularly used. So the person who invented zero long time ago can force it. No, no, Larry, no, no, that's not the case. The person who invented zero long time ago can foresee the future. Actually, I will tell you what happens is, see, let's say whenever you're working with any deep learning application, today so many applications are coming up. So let us say another new application is coming up, and in designing that particular operation application, we realize that there is something which we require very frequently, and for that I need to copy that code again and again. So I'm going to store it as a function. Now where to store it? So all such functions are dumped inside numpy, pandas, scikit-learn, scipy, and the matplotlib and cmod. So this is the place where all of these functions are dumped. So therefore they are called as one of the most fundamental libraries for understanding the machine learning thing. Therefore you always start with this, and then as and when it is realized that there are some important functions which are required, what happens is this: the version of the numpy gets updated. If there is something new which is updated, which is very useful, add it to the numpy and release it as a new version. Okay, and we have an array including both zeros and ones. Yes, you can certainly have that, Manoj, but by creating it manually. Okay, not like that. Okay, now zeros once is done, there is something which is called as zeros like. I'll explain you that as well. So I have this np.zeros. Okay, so what am I going to do is, let's say I'm storing it in X, and I say print for me X. So we know this is what is going to be printed. Now I say over here, or let's say not zeros one, I will say I want to create a NumPy array. Let's say whatever we did create up. Where is this NumPy array? 2D array. Long time. It went up here. Let's say this is the NumPy array which I want to create. Control V. We need not even write it on different lines. Okay, it's okay to have it on the same line either. It doesn't make any difference. This is only for better understandability that I wrote it. Ideally, this is how I always write it. Okay, so this is how my NumPy array is, and now I say print for me arr.shape. So it says that hey, I am 3 rows and 4 columns. Now I go to zeros like I say np dot zeros like of arr. You know what will it do? It will create a matrix of all zeros of dimensions 3 rows and 4 columns. Why? Because this matrix has the dimension 3 rows and 4 columns. Therefore, zeros like is going to create a matrix of 3 rows and 4 columns containing all zeros. In the same way, if you replace over here as ones like, is going to create a matrix of all ones. Okay, again, this is useful in deep learning applications, not important so early, but of course we always teach it. So now, having understood this, the next important thing which I want to talk of is the identity function. So let me know, guys, what is exactly an identity matrix? In simple words, you can write in any code language. Identity matrix is, what are the properties of identity matrix? It has blah 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 blah. What is that? Forgot? Mathematics, basic school level maths. Identity matrix, it's a square matrix. Am I correct? Yes. Okay, yeah, Pranit, what you said is correct. It's a square matrix, precisely what you want to say. Yes. So, and the diagonal elements are 1. Perfect. So if I want to create an identity matrix, I can use the np dot identity function, and I can say, hey, I want to create an identity matrix of 3 rows and 3 columns. So I say, okay, let me pass over here 3 comma 3. It doesn't work. You know why? Because I told you, right, NumPy is smart. NumPy says, hey, I know that it is a square matrix with ones along the diagonal. So no need to be over smart. Just type 3 and I will give it to you. Again, this is NumPy's way of, or NumPy's style of showing it with all floats. But that's how it works. So you understand over here very clearly what is the meaning. So we have studied a lot of functions of NumPy. At least 12 to 13 functions are over for the day. Now, next is, I want to talk of that. How is NumPy actually there? So whenever you talk of NumPy as a module, just now we realized that this is a very big module, point number 1. Just now we also realized that this module consists of very good functions. The very first one is the array, then the next one is my sum, then the next one is my standard deviation. I also have mean as one of the function. I also have what was the other function? Identity as one of the functions, zeros as one of the functions, zero likes as one of the functions, so on and so forth. Now these all are generic functions. You know, there are some functions which actually belong to a certain category. For example, there is NumPy is a module. Inside NumPy, there exists another module which you can consider it as a sub module. This is a module which resides inside NumPy, and it also has functions like rand is there, rand n is there, many functions are there. Today, right now, I am interested only one of the function, but I am also interested in showing you how to give a call to this function. So as you can see over here, that my random function, if I want to call my random module, then I need to say np dot, np is numpy. And if I want to call any of this function, I can straight away call it. But I want to call a function which is called as rand n, which is there inside random module. So how do I say? I want to go to random module. You need to type random, then dot, and then you say these all are the functions of my. If I just say dot, so many functions are there inside my random, so many. So you can understand how big it is. Okay, so many. I'm going to use rand n. So let us try to understand what is this going to do. So if I say 3,4 and I execute this, well, it generates a matrix of 3 rows and 4 columns. And you should also see that these values are very much centered around 0. You didn't get it? Wait a minute. Let me store it inside X. Let me print X, and let me also print np dot minimum of X, and let me also print np dot maximum of X. And when you execute this, just a blank print. Yes. When you execute this, you can see over here that when I execute this, the lowest value is -2, highest value is +1.5. Precisely all of these numbers are scattered in the range -2 to 1.5. So can I say these numbers are very near to 0, centered around 0? Precisely, I say these numbers are centered around 0, not necessarily equally near to 0. This is 1.9, this is 1.5. I executed once again some other random numbers would be generated. But you should realize again one thing, that these numbers are again centered around 0. This is 1 and this is -1.8. It's not like that all the numbers are coming on the positive side. They're centered around 0. If I execute it again, let's say over here once again you see centered around 0. Again, all of these values are randomly generated and they are more or less centered around 0. This is what we realize. Okay, so why did I do this? Because I want to use it down the line. As of now, you understood how to use the rand n function. In the same way, there are many functions. As and when required, we will use them. Not all of a sudden today itself. Else, our entire life will go in only understanding NumPy, and we don't want that. Okay. What is this? The next thing, our indexing slicing is already done. Now I want to talk of arrange function. Before that, should I take this or should I not take this? This is what I'm thinking. Let's look at it later, not right now. The next function which I talk of is, which is very important, which is range function. I will like to know it from you. Have you studied the range function of Python? Very good. So you know range function of Python. That's a very good news. So there's a question for you. What is range of phi going to generate numbers from where to where? 0, 1, 2, 3, 4. Wow, that's very fantastic. And if I say range of 1, 19, it is going to generate Kadazi, Kadahizi. Wrong. 1 to 19 will generate 1 to 19 minus 1. As Manoj said, it is 1 to 18. It will start index will always remain as start. Only end index becomes end index minus 1. Okay. Okay, one last question. Just explain me the logic. If I say 2 comma 10 comma 2, what is exactly getting generated? Step is 2. Correct. Step size is 2. So it is going to jump from 2 right up to 10 minus 1 with a step size of 2. You all got it right? Well, this is your arrange function. So now you may say, sir, then how is it different? Well, I am saying it is not different. This is your arrange function. The only thing is this is available inside Numpy and range function is available inside Python. So this is available inside Numpy and range function is available inside Python. Okay. So if that is the case, let us try to use that. But you know, there was one drawback in Python. If I am trying to use the range function and if I say, can you print for me a range of 5? It doesn't print. What to do to print the range of 5 in Python? What do we need to do? If we want to print the range, what should we do over here? Tell me, you forgot last week's progress. What to do? For loop. We need to use a for loop for printing it, right? In simple words, Mahmoud, we need to use a for loop. Am I correct? So I need to write for I in this particular thing. Can you please print for me the value of I and it gives me, right? All of you got it now? Yes or no? Is it now clear? Yes. Now, this is range function, but I don't want this. I'm talking of NumPy right now. So I'm talking of what? Range. How to use it? Np dot range of, let's say 5. I did not use a for loop. I did not use a for loop. It's not required. Okay. Now, after this, the next important thing, I can also say np dot range of 12 comma 40. Now let's say 41. So you see over here, it works fine. Okay, there's no doubt that it won't work. In the same way, let's say comma 2. That also works over here. So we understand it's one and the same. So why did I teach you this? Because remember I told you that NumPy is very fast. Can you tell me why? What was the reason for that? I did state it above. Right. A vectorized background is C++. They are very fast because of that. They are vectorized functions. Okay. So now let me actually prove it to you. Let us prove it. And for that, I'm going to look at the time complexity of my normal Python versus my Py. So what am I going to do? Well, I say we will create two lists containing 1 million numbers each. Okay. Thereafter, I say we will add them both and we will measure, rather I would say track the time taken to execute. Now you may not take the code that seriously as well. This is just for performance analysis. You may never ever require this after in your lifetime. I'm going to import one more model which is called as time, and I'm going to declare a variable which is called as size, which is equal to 1 million 1 0 0 0 0 0 0. Then I'm going to create Python objects. In my case, it is going to be lists. So let us say that one be a list which is obtained using range of size, and you know what is it going to generate? Similarly, this is my L2 generating the same thing. Yes, same thing. Okay. Now, in the same way, I'm also going to generate ND array. How? Let us call it as A1 is equal to dot a range of size. It's going to generate the same thing. We know it, right? And np dot a range of size. Cool. Now, you know what? Why did we import the time model? Because I'm going to add. Now, what is my main aim? I'm going to add. So what is this list generating? 0, 0, 1, 1. I'm going to add this 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, so on and so forth, right up to 1 million and 1 million. And I'm going to measure how much time do I take to calculate the addition of this or the sum of this. In the same way, I'm also going to do the same thing for this 1, 1, 1, 1, 1. And I'm going to see how much time do I take to measure the sum of this. Okay, so this is what I'm going to do over here. How much time do I get? How much time do I take to measure sum of this plus this, this plus this, this plus this, this plus this, so on and so forth with respect to my Python objects? Same thing with respect to my Numpy objects. Let us see how. And for that, I imported this time. This is not imported for time pass. It is imported for a crucial reason. So I say, initially, let's add L1 and L2. So how am I going to capture my system time? By using the time.time function. This is the normal function of Python. What does that do? It captures the current time. Now, if you understand this, well and good. If you don't understand this, still well and good. Not a reason to worry. At this moment, it's not important. List comprehension. If you have done this before, congratulations. If not, please ignore at the moment. For x comma y in dip, because our main aim is NumPy. This I'm just showing you as an additional exercise. Ideally, I could have skipped it. So as I told you, it is going to perform 0 plus 0, 1 plus 1, 2 plus 2, 3 plus 3, right up to 1 million plus 1 million. And this addition would be stored inside a variable which is called as result. Now, I'm not interested in the output, what it looks. I'm interested in how much time does it take for this line to execute. So I have started my timer and I have captured the start time. The same way, I also want to capture the end time. So what do I say? Stop is equal to, let's say, time dot time. Again, I'm capturing the current time and I'm going to print the difference. So I say print total time taken to execute addition of Python objects is how much, comma, and that is going to be my stop minus start. Let me tell you the time is captured in milliseconds. So multiplied by 1000, because 1 second is equal to 1000 milliseconds. That's done. The same way, now let us do it for list as well. So copy, paste, and now I say let's add, instead of L1 and L2, A1 and A2. Start is there. Now for NumPy addition, you need not write this. You can simply say A3 is equal to A1 plus A2. That's how cool it is. Simple. And stop, and time taken to execute addition of NumPy objects is again going to be the same. Okay. I'm not interested in printing anything. As I told you, I'm not interested in printing. I just want to get the addition. Do you all get the code, whatever is written on the screen? Is it understood to everyone? It's simply adding the things. If you don't understand the results line, that's fine. You can ignore it as I told you. Perfect. So everyone gets the code over here. Carlos, please change your messaging mode from direct message to everyone so that, you know, later on if you question, everyone comes to know that. Let us execute and see how fast is NumPy. Perfect. Thank you very much, Carlos. Now executing it, you will see there is a significant difference. My God, do you realize where is 2 seconds and where is 190 seconds? Yes, you understood why do I call Python as one of the slowest language? Do you get this thing? Is it clear to everyone? Why is NumPy very fast? Why is it vectorized? Therefore, I say whatever line did I write at the top, they are very, 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 very important. Okay, it's super fast. It's super fast. However, if you ask NumPy to do small operations, then at times you may find that Python is faster. Huh? If you ask him to do addition of just 10 numbers, sometimes you may see that Python is also faster. But if you have huge number of operations, NumPy will do it in no time, as good as no time. That's how fast NumPy is. Cool. So now, having understood this, let us go ahead in arrange function is done. Now I want to talk of the next type of function, which is, what was that? I wanted to talk of reshape. Once again, we executed this. See, this is 3 seconds. This is 224 seconds. Let's try it once again. Once again, more or less, you see the difference, right? Now, the next thing, we want to talk of the reshape function. What is the reshape function? Well, let me first of all show you the arrange function. Let's say I have arrange and well, so you know that my arrange is going to generate me these numbers. Let us store it in some array. Let's say X. And I say, hey, can you print for me X? Yes, that's printed. It's a NumPy array. Then I say, hey, can you print for me the shape of this? Yes. Why is it 12 comma? Because it is a 1D array consisting of 12 values, and therefore this is the shape that you get. That's fine. But I'm talking of reshape, right? So now I say X is going to be is equal to X dot reshape. Let's say 3 comma 4, and I say print X and print X dot shape. Now please observe over here. Yes, please observe. What did I do? np.arrange of 12 has generated me this. That's perfect. After that, I try to print the value of X. So that printed me this. Then I tried to print the value of shape of X, which is 12 comma, because it consists of 12 values. Then I left a space. That's perfectly fine. Then I say, hey, I want to reshape X to 3 rows and 4 columns. So if you observe, this entire thing is now reshaped to 3 rows and 4 columns. And after that, once I check the shape, obviously, come on, if I have reshaped it to 3 rows and 4 columns, the shape has to remain the same now, because I changed the shape and stored it back into X. Now, the moral of the story. Moral of the story is I can reshape. How? Well, this is still a too harsh way. I will straight away make your things a bit much simpler, I would say. I will say why to write so many things when the same thing can be done over here in a single line. np.arrange of 12. Further, reshape to 3 comma 4. Sorted, right? I mean, that is just for explanation. Now we understand this, that this is how we do it. There's a catch over here. Catch over here is that this number should be equivalent to multiplication of these two numbers. If it is not, then the reshape cannot be performed. 12 values are there. So excuse me, 12 values are there, and 3 into 4 also 12. Okay, Arnold, I am just talking the same thing. Hold on. Okay, so 12 values are there. No, don't need to be sorry. It's okay. So there are 12 values, and I have reshaped it to 3 rows and 4 columns over here. So the multiplication is very important to be the same. So if you say, hey, can I multiply 4 and 3 over here? Allowed? Yes, very much allowed. Can I have 6 and 2? Yes. Can I have 2 and 6? Yes. Can I have 12 and 1? Yes. That means there are going to be 12 rows and just one column. Can I have 1 and 12? Yes. Unless and until the multiplication of this turns out to be 12, there's absolutely no problem. You can try with all of the possible combinations. So if I say over here, just a second. There was a mosquito. I don't know from where it came, but now it's dead. Let's say 6 rows and 2 columns. You see, 6 rows, 2 columns. So reshaping is fine. But now, as Arnold asked me, can I reshape it to 2 rows and 8 columns? So I'm trying to accommodate 12 values in 8 locations. Don't do that. Okay. So I'll keep it in raw NB cell so that it doesn't get executed. Okay. Similarly, if I say I'm going to reshape into, let's say, 3 rows and 12 columns. Again, 36 values, not allowed. Marked down. Oh. Just a second, I'll just drink some water. There's something cooking in the kitchen, and I think chilies. In Marathi, what we call is, I don't know if you know Marathi. In Marathi, we call it as pizza, item which is made only from chilies. Okay, so people who are not from India, you can just make a note of this name. It's super, what do you call, spicy, but we love it. So yes. So Manoj is asking, in real life scenario, reshape is required? Yes, reshape is very much required. And again, oh, that was a very good question. I forgot to tell you. Good, you asked me. Reshape, it is again required for ML data sets. We will be using that too in due course of time. Also, it is required to reshape images to different sizes. Yes, it is very much required. Okay, so it is required. We are going to use it for our ML datasets as well. Kada is saying, is it strong? It is super strong. I mean, I am sitting over here with my door closed, and all of a sudden I started experiencing this coughing. It's super strong. Strong chilies, right? My father just loves it. Even I love it, but I can have it in a very small quantity. Else the next day morning it speaks for whatever you have. I hope you get it. So not cool, hot. So yes, so I was talking of reshape. So this is how my reshape works. There's another version of reshape over here. I can say np dot arrange, let's say 12. You know what, I can also say it like this. Can you reshape to 2, 2, 3? Now the question is, what is this? Well, it means I want it to be reshaped to 2 matrices, each of 2 rows and 3 columns. Please confirm. I am having 2 matrices over here. So you may ask me, then how is it stored? Well, it is exactly stored as you are thinking. This is 2 rows, 3 columns. Yes. This is also 2 rows, 3 columns. Yes. What are the values over here? 0, 1, 2, 3, 4, 5. Yes. 6, 7, 8, 9, 10, 11. Yes. How is it stored? Well, let me tell you over here that this entire thing is called as my 0th array. This entire thing is called as my first array, point number 1. Now inside this 0th array, this is row number 0, row number 1, column 0, column 1, column 2. So since it is row number 0, let me write it like this. Since it is row number 1, let me write it like this. And since it is stored all together, let me write it like this. Similarly, inside this array number 1, this is row 0, row 1, column 0, column 1, column 2. Since it is row 0, let me write it like this. Since it is row 1, let me write it like this. And since this is stored together, let me write it like this. And since all of this is also stored together, let me write it like this. And now if you compare whatever you got over here with whatever you got over here, it's one and the same, right? It's one and the same, right? So what do you see over here? Well, I have two arrays of size 2D. So wait a minute. What if I say x is equal to this and I say print x and I say print shape? You can see the shape is now coming as a 3D because it is a 3D data structure. Not convinced? Wait a minute. Let us try our endim function. Endim of x. You can see for the very first time, this is a 3D structure. It's a 3D structure, and you see over here, it's saying the same thing. Again, one important thing over here, okay? Multiplication of these 3 should come out to 12, else it's a total fail. Now you understand it. 2 2s are 4, 4 3s are 12. By hook or crook, this has to be not a single value less than or greater than 12. It has to be compulsorily 12 only. Okay, that is point number 1. Let us do indexing over here. So let's say if I want to access the entire array 1, what am I going to write? Well, I will say x of 1 and I get the entire array 1. Yes. Okay, let's say in my entire array 1, I want to access row number 1. So what am I going to write? The same thing, 1. Am I getting my row number 1? Yes, 9, 10, 11. That is my row number 1. And if I say, hey, I want to access only the number 10 over here, only 10 over here, then I say inside this, 1, 1, 1. And it's going to get me a single number which is called as 10. So you understand over here this thing, right? So a lot of things over here for us to understand. Seems easy and convincing to us. Now, once this is done, the next thing which I want to talk of is what can be considered. Okay. Operations on arrays, we can start with the next part over here. Okay, let me see. There are some questions. Let me check that. Means array 1, row 1, column 1. Perfect. That's exactly what it means. So before I answer Larry's question, let me ask you all guys just for a confirmation whether you have understood or not. Friends, I want to access, let's say, number 5. So tell me, if I write x over here, what is going to come in this 3 square bracket? Just tell me the numbers over here. Without any mistake, I give you one more chance. Those of you who answered, please hold on. One more chance. Read properly. Which array, which what. Read properly and then answer. Which array, which row, which column, read properly and answer. Just write the 3 numbers. You need not even write the square brackets. I'm fine. Yes, now I see the answers coinciding. I'm talking of the 0th array. I'm talking of the first row inside 0th array and the second column inside the 0th array. So 0, 1, 2, 0, 1, 2, Larry, it's 0, 1, 2, 0th array, first row, second column. That is exactly what I'm talking of. So those who think went wrong, one last question for you. What if I want to print 7? Tell me what to do if I want to print 7. What are going to be the values over here when I say I want to print 7? Those who went wrong, only they should answer. Others need not. You can keep your answer to yourself and check it later. Okay, let's confirm. 7 is in which array? First array. Inside this, it is in which row? 0th row. Inside 0th row, it is in which column? First column, 101. And yes, you all answered that only. That's correct. So you understand over here very clearly how the concept goes. So that's sorted. Now, one question which I missed. What is that? Just let me check out. Since we are talking about images, can you pad zeros or ones if your array is coming less than 12? Yes, you can do that as well. There is numpy function to pad. I don't remember the syntax for it. Practically not possible to remember lakhs of functions available. So we can just numpy add zeros to array. Just Google for it. In the very first hit, you will be getting the documentation. If you find the documentation a bit confusing, you can always visit Stack Overflow. So where is this? Padding, b dot shape. Is there any pad function over here? Can't find it. np.pad. Okay, you can have a numpy.pad fall give the path and the padding width. So if you have an example over here, have they written an example? Yes. There is an array 1, 3, 2, 5, 4, and I say pad what? What to pad? X has to be padded with 3, 2 constant values is equal to 6, 4. So 1, 3, 5, 4, 1, 3, 5, 4. Need to check. A bit clumsily explained over here. You should read the documentation, then it will become clear. But right now, the moral of the story is yes, it can be done. How to do it? I think you can explore that later as well. You understood the concept behind that? It can be certainly done. Perfect. So going ahead. Now, the second part. What was the second part? I don't remember. You remember? The second part which I said we are going to cover in the NumPy. What was that called as? Sci-fi? No. The part of the NumPy. The part of the NumPy which I told you that we'll be covering after an hour. U functions. Correct. So we are going to talk of U functions now. U functions are nothing but the universal functions. So what are exactly universal functions? See, we have to understand that most of the NumPy arrays are achieved, or most of the operations on NumPy arrays is achieved by using the universal functions. So to be very specific, NumPy provides a rich set of functions that we can leverage for various operations on the arrays. And universal functions are such functions that operate on arrays in an element by element fashion. So they operate on arrays in an element by element fashion. Again, the implementation of the U functions is vectorized, which means that the execution of the U function on arrays is very fast. They are implemented in the NumPy packages in the pre-compiled C or C++ codes for speed and efficiency. So let us see. So I say over here, guys, let's create an array np dot range of 5. Now this is where the beauty of NumPy comes, and all of these universal functions are heavily used in deep learning. Heavily, literally very heavily. Okay. Now, in fact, to some extent, it is used in machine learning as well. But most of the times, in my experience, I have found that it is used in the deep learning applications. So if I say dot reshape, I can write over here 3,5. Yes, certainly. What did I do? AR. Oh, 3,5. My bad. It is 15. So that is done. Now what am I going to do is, friends, tell me, is this a valid operation? Can I add 5 to this? Look at the dimensions before you comment. Array is having the dimensions 3 rows, 5 columns. And I want to add 3 rows, 5 columns with a single value. What have we learned in school? Can you add this? Can you add an array with a single value? You can. Which school you belong to, Manoj? I never studied it in my school. In my school, I was taught that if you have an array maybe like this, and if you want to add it with some other array, it should be compulsorily of the same dimensions. Then only we can perform element by element addition. 3, 2 plus 1, 3, 3 plus 3, 6, and 12 plus 7, 7, 8, 9, 19. Am I correct, Manoj? This is only what we learned in school, right? And this is as per matrix rules. The rules of the matrix says that if this matrix is of m cross n, then it can be added with only one matrix of size m cross n, and the output will again be m cross n. Am I correct, Manoj? I hope you recollect this. This is exactly what we are taught in school. Am I correct? Yes. I'm not talking of NumPy at all. I'm not talking of NumPy. What was my question? What did we learn in school? Can we do this? And the answer to that is no. Of course, NumPy can do it, but let's try to understand it the generic way first. So if you say NumPy that, hey, this is my array and I want number 5 to be added over here, NumPy says, hey, I can do it. But how? How can you add 5 over here? Because we just understand that if this is of 3 rows and 5 columns, NumPy says, how can I add 5 over here? NumPy says, no worries. I have a function which is called as zeros likes, ones likes. In the same way, I can also create a matrix of 3 rows and 5 columns. 1, 2, 3, 4, 5. And I will broadcast this 5 everywhere. I'm going to broadcast this 5 everywhere. Now can I perform addition? Yes, corresponding elements addition, and that's exactly what you will get when you execute this. So you can confirm your addition answers everywhere. 5 is added. That is the beauty of this. So I say over here that the above concept is called broadcast, which converts a single element, which is specifically 5, into an array. Another thing, broadcasting happens on its own. It happens on its own. You need not do that. As simple as that. A very interesting operation. Similarly, if this can be done, then why can't the operation like this be done? Obviously, it can be done. Every value would be multiplied by 5. One very good operation which I will like to show you. If I have an array 1, let us say that is equal to np dot a range of 15 dot reshape to 5,3. ARR2 is equal to np dot a range of 5 dot reshape to 5,1. Let me print that for you. So that's my ARR1, that's my ARR2, and I say, hey, I want to perform addition of ARR1 plus ARR2. This is against our matrices rules once again, because if I say I want to perform the addition of these two values, how can I think of adding it? Now, everyone listen. I'm going to explain this only once. Usually, I always get a request for repeat. So I am giving an alarm signal to you right at the start. Focus 100% of your attention. So you see over here, you realize over here, this is of dimension 5 rows and 3 columns. And this is of dimension 5 rows and 1 column. Because there is one parameter which is common, I can think of adding this. What happens over here if I place it just next to it? If I say, hey, I want to add 0, 1, 2, 3, 4. Well, it can't be added because it is 5 rows and 1 column. So broadcast says, hey, hold on, I can do something. So I can replicate whatever I have once again, 0, 1, 2, 3, 4, and once again 0, 1, 2, 3, 4. And now if you look at this, this is of 5 rows and 3 columns. Now the corresponding elements can be added. Yes. Do you get this concept? One parameter should be common. One parameter should be common, else this broadcasting won't happen. So if you say that there is one matrix of 3 rows, 4 columns, another of 6 rows, 1 column, can we broadcast? No, that will not happen. And that will not generate a logical output as well. Yes. So now if I execute this for you, you can see over here, I get the corresponding additions, right? First row is added with all the zeros, therefore it remains as it is. The second row is added with all ones, so 3, 4, 5 become 4, 5, 6. The third row is added with all twos, so 6, 7, 8 will become 8, 9, 10, so on and so forth. Last and second last rows also get added. Is this operation clear? Okay, Pranit is saying it has to be like column of the first matrix equal to the row of the second matrix. Am I correct? Is it working in that way? Column of first matrix is equivalent to the column of second matrix. So in that case, Pranit, it's not that case. So let us try executing the cases which you are saying. Okay. So adding, pasting. What if I say this is done? Please observe over here. This is 5,3 and let this be 1,5. Does it support the broadcast operation? Well, it gives me an error. Okay, fine. Let us confirm with column wise. So let this be 3,5 and 1,5. Does that support a broadcast operation? Yes. So either the rows should be same or the column should be same. As you can see in the above case, we have the number of rows as 5,5, broadcast operation supported. In the next case, we have the number of columns as 5,5, therefore the broadcast operation supported. So what you just said, Pranit, doesn't fit over here. Rows should be same, columns should be same. Make sense? Clear to you? Perfect. Okay, now let us do some of the linear algebraic functions. So this is where our SciPy actually gets started. Without introducing you to SciPy, I'm still starting with SciPy. How come? Because SciPy is basically going to do the same thing over here. Linear algebra using Numpy. So again, we understand that linear algebra is an integral part domain of machine learning. And most of the algorithms that we are going to deal with in our machine learning is going to use linear algebra to a humongous extent. See, understand over here, Numpy was initially built to provide the functions which are very similar to MATLAB. which was an image processing application or a software. And therefore, linear algebra functions on the arrays are always important part of it. So today we are going to learn a bit more of performing linear algebra on ND arrays using the functions which are implemented in Numpy. And most of the operations which are used in linear algebra is nothing but the dot product. Simple, a dot product and you get the answer. Not convinced? Hold on, I will show you. The very first operation which I am planning to do is, let's say, matrix multiplication. So from where to get the matrix? Let me build it. A is equal to P dot array. I can take this now. Why to unnecessary waste my time? That's sorted. And that's sorted. This is of 3 cross 5. Then second has to be at least of 5 cross, let's say 2. Then so let this be 10. Then let's keep it very simple. And how to do the matrix multiplication? First of all, let me print my ARR1. Then let me print my ARR2. And if I want to print it, how to do? Well, let us use only the dot function available. How? A with dot function of B. That is going to be simply like saying A has to be multiplied by B. And 3, 5, 5, 2, M into N, N into P. Oh, that's fine, right? A is not defined. Oh my God, it's ARR, right? Let us convert it. This is ARR1, ARR2. I get it. Perfect. Simple way to perform matrix addition. Okay, now that we understand this, the next thing is what we are going to talk of is transpose of a matrix. So let's say I have an array something like this. Let's say I print ARR1. How to get the transpose? Well, simply ARR1 dot P. Yes, that's it. Dot P. Transpose is going to be like this. 3, 5 will be converted to 5, 3. And we all know what is transpose, right? So I did not talk of that. Similarly, the next and the important thing is I can also solve linear equations. Yes, I can also solve linear equations. So linear algebra is most often used to solve the linear system of equations. Let me remind you, have you ever solved problems like this? Let us say you have 3 equations given to you. First equation is, let's say, 7x plus 5y minus 3z is equal to 16. Then 3x minus 5y plus 2z is equal to minus 8. And 5x plus 3y minus 7z is equal to 0. Find the values of x, y, z. Did you all solve problems like this somewhere before? Yes, no? Do you remember? There were some problems like this in our school mathematics. Yes, long time ago. So NumPy can solve it in a fraction of seconds. So the only requirement which NumPy says over here is, NumPy says, what you do is, whatever things you have on the LHS, give it to me in a single array. Let's say I call it as A. And whatever things you have in the RHS, give it to me in another array. Let's say a B. And after that, I have a sub package which is called as linear algebra. So inside NumPy, we understood there was a sub package which is called as random. Now we are getting introduced to one more sub package which is called as linear algebra. And inside linear algebra, there is a function which is called as solve that will do the things for us. So let us try to do that. So I say over here, let my A be numpy.array, and I say it's going to be a 2D array because there are 3 rows to be substituted. What is the first row? 7, 5, minus 3. 7, 5, minus 3. Sorted. What is the second row? 3 minus 5, 2. So 3, minus 5, 2. Okay, sorted. Third row, 5, 3, minus 7. 5, 3, minus 7. Done. B matrix done. Now B matrix consists of just 3 values. So I say dot array, and this time 1D array is sufficient. 16 minus 8, 0. 16, minus 8, 0. Sorted. Yes. Now what to do? Simply call np dot not solve linear algebra dot solve for a, b, and don't be surprised. Here are the answers. Find the value of x, y, and z. These are the values of x, y, and z. Solve it at your home and confirm it later on. So that's how you can do such operations on NumPy. So it is a very powerful thing, I would say. Okay. Now, after this, now we can actually start thinking of going to our SciPy. So we are on the correct track. Perfect. Let's get started with our SciPy now. Now, as I told you, I mean, I'm not going to get into the nitty-gritty details of SciPy because it's again a big module, but NumPy is something which is very important for us. So I say SciPy. Okay. Now the question is, starting with SciPy, we understand that whenever it comes to mathematics, we deal with huge number of concepts, and we know that everything is important, but at the same time, it is complex as well as time consuming. Therefore, Python provides us a full-fledged SciPy library, which helps us in doing all the scientific calculations. So what is exactly SciPy? Well, SciPy, I would say it is an open source Python. Open source means free. It is an open source Python library. Point number 1. Point number 2, why do we have it? Well, I say it is used to solve scientific and numerical or mathematical problems. Okay. And one more thing, why I say over here, it is not that much important for us. That is because it is built over NumPy's extension, and it allows the user to manipulate and use a wide range of high level functions. Okay. Therefore, as I said, that SciPy is built on NumPy, and therefore, if you import SciPy, there is no need to import NumPy. So I say, if you import SciPy, there is no need to import NumPy. Okay. Now, next important thing which I want to talk of is what are the differences between NumPy and SciPy? Well, they all have their own significance. NumPy has almost everything related to SciPy with a few exceptions. They all are very big libraries. Okay. Both are used for mathematical and numerical analysis only. NumPy consists of arrays, and the basic operation that happens on NumPy are sorting, indexing, whereas SciPy consists of only numerical code. So, with the help of NumPy, if you are familiar with mathematics,
You can solve linear algebra, Fourier transforms, all such mathematical problems. Whereas with the help of SciPy, you can solve fully featured version of this along with many other things. So therefore, SciPy is more powerful when it comes to scientific calculations. Okay. So now let us first of all start our journey by SciPy with linear algebra only. Same problem that we did above. So I say code and I say SciPy for linear algebra. So we need to discuss it where to download SciPy. Well, SciPy install SciPy Conda. Please observe. Do it fast. Copy this link. Yes. So depending on the OS that you have, I have Windows, so I'm just going to copy this particular thing. You need to install it, okay? Google Collab, I think you don't need to install, but ideally you need to install. You need to copy this, and then you need to open the Anaconda prompt, paste it, and enter, and it will automatically get installed. At times in between, it will ask you to press yes or no, Y/N. Make sure you hit Y. So this has to be installed. Point number one. Point number two, this is the link which I am going to paste it here only so that you have it. So I say I have committed as well. So the moment I receive the link, you can get it in your notebook as well. By the time this executes, let us go ahead. So we have already imported NumPy. Let's import SciPy. So I say from SciPy, I want to import the linear algebra module. Yes, that's exactly what we did. Now, after importing this linear algebra module, then let's say we want to solve the linear equation. This time, let me make it a bit simpler. So the first linear equation that I have for solving is, let's say, 1x plus 2y is equal to 5. And the second linear equation be 3x plus 4y is equal to 6. You can modify it for the upper equations as well. So I need to create a input array as usual. So actually, I need not do that. I can copy the code from up only. So let's say these are the equations that you need to solve. Okay, let's say copy, or let's say let's copy this only. No? Control A, Control C. These are the same equations. So okay, so I have created my array A, I have created my array B, and I say not np dot linear algebra. I can simply say linear algebra dot solve. So what do we realize over here is if I'm storing the answer, or let's say let me not store the answer, let us print it as usual. 132. Friends, do you realize, as I told you, that if you import SciPy, NumPy is not required. So if I import SciPy, I need not write np.linearalgebra.solve. As simple as that. It's one and the same. It's one and the same. They are just, the baby products of SciPy. As simple as that. Let's say now I go to look over here, 132. And over here also I have 132. So that means it's one and the same. I need not write np dot because I'm using SciPy. As simple as that. Now after this, uh, let's say I want to find the determinant. Well, in NumPy also I can do finding the determinant over here. Absolutely not a case. So let's say if I have an array over here and I want to find the determinant, let's say let us consider a very simple array. A is equal to numpy dot array, and inside this 1 comma 2 comma 3 comma 4. Now please don't ask me, sir, what is determinant. Determinant is determinant. We all have studied in school days. So if I want to calculate the answer, I can first of all say I don't need to print, or let me print A. I mean, there's no harm either. So this is how my A looks like. So let's add a blank print, and then I say print linear algebra dot determinant of A. See, I get the answer. In fact, what I want to tell you is I can also write it using NumPy just by having np dot, and it will still give me the same answer. Now, yes, please don't debate that this is more accurate compared to this. We don't give it that much importance. Yes, no doubt it is more accurate, but it's fine. Okay, so this is what we have. Now the next thing which I want to talk of are the SciPy constants. Well, there are multiple constants in SciPy. One of the constant is called as pi. If you want to see that, well, first of all, let me show you the numpy constant. I can say numpy dot pi, and I get the answer. Wow. So obviously, if this is a constant in numpy, then it exists in SciPy as well. So I say from SciPy import pi. In fact, the same constant exists inside math as well. Inside math package, let us use all of them. So I say print for me SciPy dot constants dot pi. Constants dot, why is it not coming? Pi. And similarly, I can always say print math dot pi. What is the problem? What is the problem? What is it saying? SciPy is not defined from SciPy dot constants. And now if I say dot, why is it not coming? SciPy dot constants dot phi. Why is SciPy not defined from SciPy dot constants? Carlos is saying just print pi. You mean to say drop this? Let us try this. No, it's not working. Okay, no, it has to be SciPy dot constants only. You just need to check why SciPy dot constants dot pi. Ideally, it should print. I don't think there is any discrepancy for it to not print. From SciPy dot constants import pi, that is fine. Print SciPy dot constants dot pi. It is perfectly fine. Anything wrong with numpy pi? No. Anything wrong with math dot pi? No. Okay, no problem. Need to check. Let's not waste time. But it had to execute. Very surprising. Why is it giving an error? But it has to execute. It's a valid syntax for sure. But need to check over here what is wrong exactly. So, okay, what is the question? What is the logic behind print? That is a very interesting question, Pranit. So the logic behind print is nothing but this. it is basically dealing with printing the things on the screen. So a lot of things are available inside this print function. So whatever you want to print, what is the separator that you want to use for printing, what do you want to end the print statement with, and which is the file function that you want for printing, and do you want to flush out after printing the things or not. So the main thing of printing is it is a function which is very near to the software and the hardware, because its task is to print whatever the user says. So whatever I want to do, it is going to convert it into the machine understandable format so that machine can print it on the screen. So the main aim of the print function is to take everything that the user says, convert it into the machine level instructions, and using the machine level instructions, it will now be printed on the screen. But while printing, again, the machine converts it to the user understandable format, because if we print it in binary format of zeros and ones or hexadecimal formats, it is going to be very difficult for anyone to understand. Because you import from, you only use pi. Oh, so you mean to say like that? Just a second. That also makes sense, but let me check. Oh, wow. Thank you very much. Perfect, perfect, perfect. Thank you, Carlos. And check if SciPy is installed in the environment you are using. It's of course installed. That's how you do it. Perfect. So now after this, the next thing which we can talk of over here is, let's say, some operations related to images. Okay, so I am now trying to perform opening and writing to image files. The very first thing which I want to tell you over here is, well, there is a package inside SciPy which is called as the MIST package. So I say, if you talk of this MIST package, well, it has some images for learning purposes. Let's consider one such image. So I say I'm going to use my plotting library for that. So I say import matplotlib dot pyplot as plt. Then I'm going to import image IO. Not very important, but since we need to have a session on SciPy, therefore I am taking this. Then I say from my SciPy, I'm going to import the package which is known as MISC, and inside this there is an image which is called as face. Okay, so and then I say I want to print that. So I'm going to use the image IO class. I'm going to use the IMWrite function, which is for image write, and whatever I want to write it. So I say that let's say whatever file name I want, let's say file, or let's say assume it's a cat dot jpg and comma f. That is the mode I want to print. So it is the object. It is whatever I created over here, that object I did pass over here, and then I simply say plt dot I am show of and plt dot show. Not very important, but this is just for your understanding. Right now we are not at all going to deal with it. Wow. So matplotlib.pyplot.scipy how? Where did I do that? Scipy matplotlib.pyplot, and then we say, oh, here, show that came as scipy. Yes, it's a very cute image that you can see over here. Okay, so now if I want, I can also think of performing, let's say, a blur operation over here. So if I want to apply blur filter for this image, I can do that. For that, I need to say from scipy, I need to import nd image. This is already done. Then let's say face is equal to misc dot face. We already done that. And let's say blur face is going to be my nd image dot. There are multiple filters for doing that. I'm going to use the Gaussian filter. Multiple are there. So let's say nd image dot Gaussian filter, and I have this face to be passed, and how much level of blurring I want, that is supplied by giving the right value of sigma. And then I say plt dot I am show with my blur face, and plt dot show. Let us look at this. This is with sigma equal to 3. Let us try sigma is equal to 1. You can see, then let's say sigma is equal to maybe 10. You can see it is becoming more and more work. So sigma is nothing but the level of tuning. So sigma basically indicates the level of the blur. So I say sigma indicates the level of blur, whatever we wanted. Okay. Now, after this, I'm just thinking whether I should. Okay, let us use some other operations over here for blurring. Do I have anything else? So instead of this, I say dot. So many filters are there. Sobel. And what does Sobel ask me? It just asks me for the input. What was our input? Face. Let's say face followed by any sigma value. No. So I say face. Well, you see, this is the same image. This is the same image. So this is what Sobel operator has done. It also does the same thing, but what all are the documentations over here? Well, ask me for access is fine, this is fine, output is fine, mode, str or sequence, reflect, constant, mirror. Okay, I think nearest, mirror, wrap, that we can do. Mode is equal to nearest, mirror, wrap. So I say mode is equal to nearest, mirror, wrap. This is mode is equal to reflect by default. Then nearest looks more or less the same. And let's say wrap. So it's basically blurring. So that's how my Sobel works. Is ND image an alias name? No, it's a proper module name. It's not an alias name. It's a proper module name. Okay, so that's how it is. Then similarly, you have Privits Operator as well. Let us try to use that once again. So as I told you over here, let this go down. Privit. And I'm going to take this. And I don't know whether mode is there over here. Many functions, right? But these are good operators. This is what Privit has done. So what are the different things that Privit has inside this? Let us check that. It also has different modes, very similar. So we can use the same mode over there. Mode can be reflect or constant nearest mirror. Mode can be equal to mirror. So this is how the mirror mode looks like, and the mode can be constant as well. Mode can be constant, and okay, this is how it is. Okay, Manoj is asking, is it possible to make a clear image from a blur image? Well, yes, it is possible to make a clear image from a blur image, but you will not get that good quality. See, what happens over here, Manoj, is whenever you talk of image, well, if I say that this is a bad image, so the only thing is image basically consists of pixel values, and these pixel values are nothing but numbers which range between 0 to 255. So possibly there is 1 or 11 over here, 25 over here, 100 over here, 16 over here, 219 over here, 12 over here, 53 over here, 70 over here, 57 over here. Now what do you do? Well, what is done over here is, if you want to make this image a bit more clearer, what they say is, whatever pixel you have over here, just repeat that multiple number of times. That is the only option available to make the image clear. So ideally I can say that this 3 cross 3 is going to be converted to 9 cross 9, because everything would be replicated twice. Or let's say if I'm going to replicate everything 4 times, then it will be converted into 3 into 3 into 4, that many number of times. So this 11 will actually be stored like this. Then 25, 25, 25, 25. Same with 219, 219, 219, 219. Same with 12, 12, 12, 12. Same with this and this. Same with this and this. That's how this matrix actually gets bigger. So ideally it's kind of swelling the image, which will not give you the true quality, but certainly can be considered as one of the metric for working on with this. Not a guarantee that it will be one of the best technique, but certainly you can think of working with this as well. Okay, but not advisable. And to be very honest, we are not going to deal with images at all. Not so early for sure. So today we are not going to talk of images. We are only going to deal with the numbers. It is too early to talk of that, but since we had to cover SciPy to some extent, we did try that. Okay, does that make sense to you, Manoj? Perfect. One last function, just last 2 minutes, and I will free you. I can also find the trace of a matrix. What is exactly trace of a matrix? Do you remember what is trace of a matrix? Anyone remembers what is trace of a matrix? Yes. Okay. Manoj only remembers that, I guess. Assuming that yes is for this. Well, the trace of a matrix is the sum of all the elements in the diagonal of a matrix. How to do that? Let us assume you have a matrix, let's say called as X. Numpy dot array, and it's in the form of 2D array. So let's say 1, 2, 3 sorted, 4, 5, 6 sorted. Let's say 9 sorted. How to calculate that? Np dot trace of X. You get it, right? It is directly available. You need not do anything. As simple as that. Again, a good function for us. So yes, so that's it. I don't think anything extra to be discussed over here. So here I concluded our day 1. Happy learning to all of you.